So the polar vortex is when people hear that expression, they associate it with cold, wear a sweater, please don't let my furnace break down type situations. People are more familiar with the jet stream. So let me start there and tell you how the polar vortex is different from the jet stream.
Hello, and welcome to another edition of the Climate Emergency Forum. We're happy that you're here today, and today's topic is the polar vortex gyrations. The polar vortex, as many of you may know, is an important feature of the climate, particularly in the Northern Hemisphere. And we have our two experts, as always, with us today to examine what it means, why it's important, and what the scientific controversies are about the polar vortex and how it's affecting the weather that many of us are experiencing as we record this right now. So I'm Herb Simmens. I am the author of A Climate Vocabulary of the Future and a co-founder of the Healthy Planet Action Coalition. And I want to encourage you, if you like this video, to like it on YouTube, to subscribe to our channel. We have over 200 recordings that are up, to share this video with your friends and your colleagues, and to leave us comments. Tell us what you think, what you'd like us to do in the future and talk about. And don't forget to visit us at theclimateemergencyforum.org. And with that, I'm delighted to introduce our regular Paul Beckwith. Most of you know Paul from Ottawa, Canada, a climate systems scientist who has recorded and explained well over 1,000 videos on every aspect of the climate crisis over the years. And so, Paul, basically, tell us a little bit about the polar vortex and its gyrations.
Yes, thank you, Herb. So the polar vortex is when people hear that expression, they associate it with cold, wear a sweater, please don't let my furnace break down type situations. People are more familiar with the jet stream. So let me start there and tell you how the polar vortex is different from the jet stream. The jet stream circumvents the poles. If there's a large temperature difference to the equator, the jet stream is very fast and it travels mostly west to east in the zonal direction, and there's small undulations in the north-south direction. The important thing is that the jet stream is at the top of the troposphere. It's at a pressure of about 250 millibar or so, and this is important. Now, the polar vortex, we can call the jet stream the tropospheric polar vortex, if you like. The stratospheric polar vortex, or the polar vortex, is much higher in altitude. The air pressure is only about 10 millibar. So it's much, much higher in the atmosphere. And it has various modes of behavior. So it can be very strong. And if it's very strong, it circumvents, say, the North Pole in the west to east direction. And it's tightly confined in terms of, it's very, very fast. It's tightly confined and it's pretty thin in vertical dimension. And then what happens is we can have disruptions of the polar vortex. We can have it weaken. We can have it elongate and stretch like taffy. We can have it something called a sudden stratospheric warming occurring, in which it shoots up energy up into the polar vortex. It disrupts the polar vortex, which can then break down and actually even greatly slow down or even split or even reverse direction. Now, there's very complex research about the polar vortex interactions with the jet stream and also with the effects of climate change. So as you know, with climate change, the biggest factor is that the poles are warming much, much faster than the rest of the planet. And that's because of the temperature difference is lower. The Arctic is warming like crazy. So It's all connected. There's connections between them all, but the research is still out there. Most papers, I think, the consensus is if you go on to one of the AIs and ask how climate change is affecting the polar vortex. Most papers say that yes, climate change is having a big impact, but there are some outliers, some papers that say there's not as big an impact from climate change as we think. Now, the stratospheric polar vortex or the polar vortex and the tropospheric polar vortex, also known as the jet stream, although they're separated greatly in altitude or height, one of them can influence the other one. You can get air drag. They can often couple and behave in the same sort of fashion. It's been in the news a lot because there's been huge cold outbreaks deep down in the US in places like Florida, where there's actually been snowfall. While those events are happening, so all that cold air from the Arctic spills down as, the polar vortex is disrupted, all that the jet streams are disrupted, all that cold air spills down into very low latitude states. Meanwhile, the hot air spills upwards into the Arctic. So you get heat waves up in the Arctic. So it's all connected. And of course, when the polar vortex is strong, the temperatures are lower. That affects things like ozone, it affects atmospheric chemistry in the stratosphere, basically. So there's a lot of interesting stuff. We'll provide links to this video on more of the connections, but I hope that's kind of an overview for people.
Oh, thanks, Paul. You certainly helped clarified in my mind. I was reading a couple articles. I think people may or may not know I'm not a climate scientist, and so I'm learning along with the rest of you on some of the more technical issues. And I was reading two articles, one of which was making the case very strongly that the vortex is responsible for much of the cold weather in the eastern United States and so forth. And the other is saying it wasn't, that it may just be, quote, weather. And to me, it illustrated what I see as sort of two dimensions that I often see when I look at how the atmosphere responds to climate change. On one hand, it's very simple. I mean, I think you've sort of said it, Paul, that the differential between the cold in the Arctic and the warmth at the equator is being minimized as the Arctic gets hotter 4 times faster than the rest of the planet. And you would certainly expect that to lead to all sorts of changes in circulation and so forth. On the other hand, when you get into the details, as you pointed out, it's extremely complex and it's extremely difficult to attribute any particular cold spell or warm spell to the vortex or anything else. So with that, but again, appreciate you bringing that up. And I want to ask Peter Carter. I think most of you know Peter. Peter is a regular. Peter is a retired medical doctor whose specialty is climate and health. He's the founder of the Climate Emergency Institute. He's been an IPCC expert reviewer. Peter, your thoughts and questions on the polar vortex?
Thanks, Herb, and and thanks doing your very best to explain it to me. I think I'm a little bit further on in my understanding now of the polar vortex, but only a tiny bit. I agree with Herb. I read this really, really long paper. It went on and on and on, and the title of the paper was the polar vortex, but it seemed to cover just about everything. But I came out of it sort of scratching my head and not knowing where we were. Well, one thing we know is that a few years ago, we started getting these definitely atypical, unusual, some people call them paradoxical, extreme cold events suddenly coming out of nowhere, supposedly, and affecting the Northern Hemisphere, affecting United States in particular. And some of these have been really, really extreme and harsh. They have indeed been deadly cold events. So in addition to all our other many extreme weather events, we've added extreme cold. The Arctic has been doing the most extraordinary things that I know, not from anything I necessarily understand, but just looking at the data, just looking at the temperature increase, temperature decrease, which we have climate reanalyzer for, which is excellent, and looking at the actual temperature of the Arctic, which the Danish Polar Institute provides us with. So about a week ago, there was a sudden abrupt spike of temperature, and it went up higher than it's ever done before. And this reached the media because people realized that there was a very strange temperature increase happening in the Arctic. Now, for several days, looking at Climate Reanalyzer, I mean, the entire Arctic, all right over the ocean, the northern Canada, all of Greenland, has been at a very, very, very high increase in global temperature. So the global warming in the Arctic up to recently is record or meets a record. I mean, there are temperatures 20 degrees C above normal in the Arctic. I mean, these are extreme, extreme, extremes. But looking back, the Arctic temperature has really been doing the most weird, extraordinary things. There have been times when one half of this, I'm talking the winter time still, up into the spring, that one half of the North American continent has been cold, 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 and the other half has been hot, hot, hot. We're seeing things we never ever saw before. We're seeing things moving very quickly, changing very quickly. There seems to be, no sense of stability at all. This should sort of be caused and would be caused by, of course, all of the energy that we're adding to the lower atmosphere constantly, constantly, constantly. Reading that long paper and another couple of ones, I'm getting the impression that the not only that the climate models are not working, right? We do know that the temperature increase for the record 2023, the models didn't really have it up to even if you took the most extreme high. 2024, the models were out of it. This January, the record January of 1.75 degrees C in a cooling La Nina, models are completely out of it. I recall thinking to myself some years ago, we're piling all of this heat energy into the lower atmosphere. It's accumulating higher and higher and higher. Can we really expect the models, which are based actually on non-perturbed climate, to continue to work? Well, I think we're seeing them not working. I personally have a feeling that we cannot rely on them. That's pretty obvious now because all of these things that are happening, the climate scientists say, we're surprised. We're shocked. What is it? My last comment then is that a very most important to me publication came out a couple of weeks ago from the UK Met Office. I was delighted at last to find a science organization or a scientist saying that global emissions must be put into decline immediately. This is the UK Met Office. They're pretty conservative. And emissions must decline 20% and thereafter 20% every year. So, yeah, look what's happening in the politics, look what's happening in the corporations, look what's happening to China Coal. Maybe this is not feasible, but this is the science, right? And we are not hearing this at all, at all. It came out with the sixth assessment, immediate emissions decline, absolute deadline 2025. There. So we seem to be very, very interested in the science, and I am certainly, but we don't seem to be very interested in applying that science to what we need to do to prevent continuing chaotic disruption of the climate system.
Wow. Peter, let me just say you've brought up so many really important and disturbing issues and questions, a number of which we've discussed at length in previous programs we've had here. The sort of the gap between what we are observing is actually happening and what the models say, the gap between what we are observing and the messages. A few of us were in Baku for the climate talks, and what did we see over and over again, if not literally on the walls, figuratively? Keep 1.5 degrees alive when we're at 1.6 and climbing. And I understand why there's such a ferocity about not wanting to give up on that target. But are we doing more harm than good by basically making a reference or a slogan to something that is more and more divorced from the reality we experience? And of course, all these issues are basically why this channel and these talks occur underneath the rubric of Climate Emergency Forum. It is an emergency. And, I was thinking the other night, maybe it was for a change, instead of a bad dream, a good dream, that, what about will the day come anytime soon when we say we're going to close down the climate emergency forum because it's no longer an emergency and we're going to go back to our regular lives and worry about other stuff, about who's winning the football match or, what my kid's grades are in school or why my grandkid, is misbehaving, all the things in regular life, or whether we're going to keep focusing on the climate emergency. So the folks who have organized this, Charles and Heidi, you may yank me off for the next session. Can you say, Herb, you're completely delusional even to be thinking about that. But nonetheless, sometimes I can't help what my dreams say. But thank you, Peter, so much. I want to ask Paul. A question, a couple of questions, if I might. One is, do you see any? Everything is connected to everything else in ways we're trying to understand, and you've been much, you've looked at this much closer than most anyone. How is the polar vortex connected to the potential collapse of the AMOC, to the loss of the Greenland ice sheet, to the permafrost melting in the northern climates of Canada and Siberia and so forth? Do we know if there's a connection? Is it important? Is it irrelevant? Are they two different phenomena? And then anything else you'd like to add to my question or anything that Peter has said?
Yes, thank you, Peter, and thanks again, Herb. So I think it's important to, if I can point out some of the properties of both the stratospheric polar vortex or the polar vortex and what we call the jet stream, the tropospheric polar vortex. The first, one of the key, there's connections galore. So hopefully, we can just clarify this subject and you can have a look and read the papers in the description of this video and try to reach some of your own conclusions. But this should help you get started on understanding those papers, this video. Let's go back to the jet stream. It's at the top of the troposphere, the lower atmosphere. The average height of the tropopause, which divides the troposphere and stratosphere, is about 11 kilometers. But that height is actually more like 7 kilometers at the cold poles and more like 17 kilometers at the equator. Okay, so that's the first thing. So there's a huge height variation. The polar vortex, the rotation, the very strong rotation at 10 millibar pressure. So 250 millibar is about the height of it's nearing the top of the troposphere. 10 millibar is well into the stratosphere. Okay, 10 millibar, it might be 30, 40 kilometers high. I don't remember exactly, but the pressure is very low and the winds whip around very, very fast. If we have a stable polar vortex, they're circumventing the North Pole. But that whole thing, it's like a top gyrating. Sometimes the top can get unstable and it can start to wobble and it can start to, in the polar vortex case, it starts to move in sort of elliptical patterns, no longer circular patterns. It can intensify, which is what we're seeing now in 2025. And if it intensifies, it's well known that often there's tremendous heat in the Arctic at the surface, which is what Peter was talking about. In fact, that heat on the surface in the Arctic, it's driving the sea ice area way, way down. It looks like it kind of peaked in January and then it's been dropping since then. I don't think that's the final peak, but I might lose $20 on it in a bet with a friend. I think it's going to come back up again. He thinks it's peaked already. But the point is, what we experience on the surface, all the extreme weather events, is intricately connected with the jet streams and with what is happening up in the stratosphere above, because there is air dragged from, say, the polar vortex down to lower latitudes. The other thing that's key is that the warming we're seeing is tremendous on the planet, but the warming is non-uniform. We know the poles are warming much, much faster than the equatorial regions. We know that the warming distribution up through the atmospheric levels is changing. Everything seems to be changing. We seem to have destabilized the system. So we're seeing lots of gyrations, lots of variations, lots of extreme weather outbreaks. But, whenever we have a cold outbreak heading down to Florida, you can be pretty sure that the Arctic is going to be having a warm outbreak simultaneously. And those things are all tied together for sure. I'd like to just reinforce what people have been saying about the climate models. I mean, we do our best to try to model the climate system, but clearly the acceleration of climate change has gone far above what the models have been saying. And I just want to mention James Hansen's excellent work in trying to explain what is wrong with the models, what the models aren't incorporating, and why we're getting this huge acceleration of climate change in 23, 24, and it's continuing into 25 as well.
Thanks, Paul. It also strikes me that, and this is true of just about every aspect of the climate system, that I think, and correct me if I'm wrong, it seems like there's a bias, and I don't say that in a pejorative or negative way, towards looking at climate as primarily or maybe even exclusively as a physical system, a geological system of sort of dead substances of air and rocks and sun and so forth, as opposed to looking at, or rather than including the biological component of it. And then what I'm thinking about, for example, is in the Arctic and everywhere, there's from what I understand, an enormous change that's beginning to occur, not surprisingly, in essentially the life forms, the fungi and the bacteria and all the millions and if not billions of microscopic creatures that tremendously influence the ecosystems in terms of, pulling down carbon dioxide, breathing out oxygen, and vice versa. And as these extremes, particularly in the Arctic, continue and intensify, we need to pay, I think, as much attention, and many scientists are beginning to this dimension of it and how it relates and interacts with the physical environment. And of course, it's complicated enough just to look at the physical environment,
Yeah.
much less its interaction with the biological environment.
Let me just
Oh,
add one thing that's important. The ozone layer is up in the stratosphere from about 20 to 40 kilometers high. And the atmospheric chemistry up there is very crucial in terms of how the polar vortex behaves and how the propagation to lower elevations is. And, when we talk about as climate worsens, of course, there's more talk on solar radiation modification, solar radiation management, which would be putting, say, aerosols, sulfur aerosols up in that particular region. So we darn well better understand the polar vortex and the interactions with the jet streams and all these other things in order to entertain that possibility of cooling the planet with SRM. I just wanted to say that. And the ozone is very important. The ozone hole hasn't vanished. It's been large in the last number of years, large ozone hole. It's not fixed or repaired. And I just did a couple of videos on the influence of reentry of materials from spacecraft can actually modify the atmospheric chemistry up in that region as well. So that's something that's important, I think, to complicate the picture even more. Sorry.
that was my reaction, as if it isn't complicated enough. And I'm always thinking, I mean, who in the world understands this? How, we're trained in most scientists and others are trained in narrow disciplines,
Yeah.
and narrow disciplines, probably have
Yep.
contributed more to creating the problem than solving the problem. But your thoughts, Peter?
Yeah, I guess some scientists were pointing out quite a few years ago that we no longer live on the planet that we call Earth. This is now a fundamentally different planet. And I think a mistake that probably the scientists in general are making, and it's a reasonable mistake because it's what they do, is to expect to be able to develop models and project changes in the future with the same reliability that you've been doing them for about 30 years. I'm really convinced that it's highly dangerous to be relying on these models with the climate system so badly, extremely perturbed and disrupted. One thing I know and the Met Office now agreed with that, is that no matter how unfeasible we think it is, we have to put global emissions into immediate decline. We can easily do that. The public could rise up, get off their screens and television sets and God knows what, and compel the governments to do that. It should be pretty easy. After all, the governments are spending trillions of dollars on fossil fuel subsidies. They're spending more and more. We're digging more and more fossil fuels out of the ground to burn more and more carbon. We do have to have and what's been happening in North America very recently drives this home. We really do have to have a massive public, led by scientists, response to the fact that we are wrecking the climate and doing nothing about it but monitoring it.
Agreed. In one word, agreed. I guess I've come across, I'm not sure if we've discussed this before, and whether we have or haven't, we may want to do a program on this in the future, but there are a couple of very important reports that have been issued by a British sort of umbrella group of actuaries, where they basically looked at they're trying to transpose the concept of solvency. A company has to take certain actions to, ensure or try to maximize its ability to remain solvent, and looking at it in terms of, what is the risk of going insolvent? And the scientific community, because they're not usually dealing with existential issues, doesn't really have that framework. It's more about probabilities and statistical significance and all the rest of that. And so I'm not sure, while I agree with almost everything you've said, Peter, I'm not sure it's the scientists who are going to save us, but really the hard-nosed sort of risk managers, the insurance companies and the actuaries and the bankers and all that, who say, "What the hell is going on? Why aren't we doing this? You're putting us out of business. You're putting our customers out of business. We can't wait anymore until we're 100% sure of, whether something's going to happen before we act, because it'll be too late." That's not to minimize the role of scientists or criticize them in any way, shape, or form. They're absolute heroes. But I think I'm waiting for these other sectors of society to step up and do their part and rely upon the scientific information and basically translate it into a program of action. And I hope we can continue to explore that in the future. I want to thank, as always, Peter and Paul, particularly Paul, for your lucid explanations of a very complicated subject. We'll probably come back and visit this at some time in the future and see what the latest science says and whether things remain the same or not. Thanks, Peter, for your important observations about the peril we're in and the need for kind of benign uprising, if that's an appropriate term. And again, I want to remind our viewers to like us if you like this channel and this program, to subscribe, to leave your comments, to go to our website, climateemergencyforum.org, to send this video to your friends and your colleagues. I can't think of a more important set of conversations than the ones that we're having, which is why I'm doing this, and I suspect that's why Peter and Paul and the rest of us are doing this. So once again, thank you so much, and we welcome you to attend our next video in a few days. Thank you so much. Bye-bye.